Hi, today I'm going to discuss the solutions for Atcoder Beginner Contest 375, problems A to F. Let's start with problem A. For this problem, we have n seats numbered from 1 to n, and each seat can either be occupied or unoccupied. And we're supposed to find the number of substrings of 3 seats that are occupied, unoccupied, and unoccupied. So, for sample input 1, there are 2 such substrings, which is the first 3 and the last 3 characters. Let's look at the code for this problem. We first just input the string, and then for each character, we check if it satisfies that the first character is occupied, and then second is unoccupied, and third is occupied. If it does, we just increment the answer. Let's look at problem B next. For this problem, we're supposed to travel from the origin and visit all these n points in order, and then afterwards return to the origin. We need to calculate the distance to travel between all these points. And for this problem, we can just directly calculate all the distances between any 2 points and sum them up. Let's look at the code for this problem. First, we input all the points, and then afterwards, the calcDist function just calculates the distance between any 2 points. So the distance is calculated like this, and afterwards, this part just sums up all the distances that they need to travel between the 2 points and return to the origin. Let's look at problem C. For this problem, we have a square grid that is painted either black or white for each cell, and we need to perform transformations on the grid. So the transformations go as follows. The cell at y n plus 1 minus x will be changed to the color of cell xy, and the operations will be performed simultaneously for all pairs of xy between I and n plus 1 minus I. So let's further look at this problem. For this problem, we need to notice that the replacements have to occur simultaneously. So we would need to copy the original array A onto another array, say array B, and each time we will replace array A based off of the values in array B. And afterwards, we will need to copy array A onto array B again for the next transformation. However, this would time out because this would take double the time. And we need to try to optimize this approach. So we notice that for each transformation, the replacements go in a cycle. So the point y n plus 1 minus x is replaced by point xy, and so on. So this goes in a cycle. And afterwards, let's try to visualize this. So the first node would go to this corner, and this would transform to the bottom right corner, and it would afterwards go here, and this would be replaced back with the starting node. So for the second cell, this also goes in a square, like this. And so each transformation occurs in a square. So we will only have to loop through the pink cells, these cells highlighted in pink, and transform the entire grid accordingly. Let's look at the code for this problem. We first input all the colors for A, and then afterwards, this part, we perform the transformations from I to n divided by 2, as the problem stated. And for each transformation, we loop through all the pink sections that I mentioned previously, and this part is just replacing the cycle values. Like, for example, the cell xy will be replaced by the value in the cell n plus 1 minus y x, and so on. After we update it as a cycle, we just see out the answers. Next, let's talk about problem D. For this problem, we're given a string and we're supposed to find the number of palindromes of length 3 that can be formed based off of this string. So, for example, for sample input 1, we can form a palindrome with the first character A, and then B, and then A again. So let's further look at this problem. For this problem, we can calculate the palindromes by looping through each character and see whether it can be the starting character. So for the sample input 1, if we start at character A, and then it could end at the other character A. So this will form 2 palindromes because the palindromes can be ABA and then ACA. So this is just because there are 2 characters in between these 2 A's. And another possibility is to start at C. So if we start at the first C and end at the second C, then this would form 1 palindrome, CAC. And afterwards, if we start at the first C and end at the last C, then this would form 2 palindromes. So we notice that for each character, for example, if we start at C, then the number of palindromes that can be formed by starting at this character is just the distance between this character and any other character that has the same alphabet. So, which is the distance between this C and the second C, and also the distance between the first C and the last 3 C. So, we can calculate this quickly by using a prefix sum. Sum ij will represent the prefix sum of indexes of the first j characters corresponding to each character I. And because we need to find the distance in between the characters, we also need to keep track of a count of occurrences for the alphabets. So count ij will just be the occurrences of each alphabet I for the first j characters. And for each character si, we can update the answer by adding how many palindromes it would contribute if the palindrome starts at that character. So this part will just be the sum of the indexes of the characters that occur after si and have the same alphabet. And we need to subtract the beginning indexes to find the distance that are in between the 2 alphabets. So this part is just the number of characters that occur after si and have the same alphabet. And we need to multiply this by I plus 1 because we need to find the value in between. So the first section, the indexes before I wouldn't count. So let's look at the code for this problem. For this problem, we keep track of a sum and a count. And this part is just updating the prefix sum for both the sum and the count. To the sum, it will be the sum of the indexes corresponding to each character. And the count would be the sum of the occurrences corresponding to the characters. And to update the answer, this section is looping through the string and to see if each one can be the starting location. If it can't be, this is just the palindromes that can be formed if Si is the starting location. And this calculates the distance in between Si and any other character after Si that has the same alphabet. And after we update the answer, we can just print it out. Let's look at problem E. For this problem, we have n people that are divided into 3 teams, and each person has also a strength B. So we need to find the sum of the strengths for each team and try to swap the people to another team so that the sum of the strengths for each team is equal. We need to find the minimum number of people that we need to switch in order to make all teams have equal strength. So let's further look at this problem. For this problem, we can do a dynamic programming to solve this. So first, we can think about the DP states, and we can store all the states which are the first I people processed, and then J is the sum of the strengths for group 1, K is the sum of the strengths for group 2, and L is the sum of the strengths for group 3. And this DP will represent the minimum number of people who need to switch to achieve this state. However, we notice that storing all 4 states will exceed the memory limit. So we can try to optimize this. We notice that if the sum for 2 groups is determined, then the sum of for the third group will also be fixed because the total sum is already fixed. So we can only store the sum for 2 groups, because if we already store the sum for 2 groups, then the sum for the third group will be fixed. So the DP would just be DP IJK, where I is the first I people processed, and J is the sum for group 1, and K is the sum for group 2. So let's look at the DP transition. Let's say the current person I is in group 1. Then there will be 3 possibilities for this person, which is to stay in group 1, or to move to group 2, or to move to group 3. And we will need to find the minimum number of people that is switched. So DP IJK will just be DP I minus 1 J minus B K, which is the state that the person I doesn't move. And afterwards, this part is if person I moves to group 2, and the third part is if person I moves to group 3. And we need to plus 1 for these 2 because the person I moves, so we need to add 1 to the count of people that need to switch. And we would do the same thing for all the other people, and if they're in group 2 or group 3. So if they are in group 2, they also have three possibilities: to stay in group 2, or to move to group 1, or to move to group 3. And the same thing happens for a person in group 3. So let's look at the code for this problem. We first find the sum for all the people. Like, the sum would just be the sum of the strings for all the n people. And because we need to divide this into 3 groups, so if the sum is not divisible by 3, then we can just output -1, because then it would be impossible to switch people so that the teams have the same strength. And afterwards, we first initialize dp000 with 0, because we don't need to switch any people to achieve this state. And afterwards, we loop through I, j, k accordingly. So for each person, if we need to check if j is greater than or equal to b and k is greater than or equal to b, and also if the third state is greater than or equal to b, so that when we subtract b, it doesn't become negative. So dpijk would just be the minimum number of people if person I stays in their group or move to the 2 other groups. So this part we need to +1 if this group is not the group that person I belongs in. And afterwards, if this is impossible, then dpn sum would just be infinity. So for this case, we output -1, and otherwise we just output the answer. For problem F, there are n cities and m roads, and each road connects cities A and B, and also has a length of c. So we are given some queries to process, and for this, the first type of query, road I would become closed, and for the second query, we're supposed to print out the shortest distance from city X to city Y. And we can only use the roads that are not closed. And if this is impossible, we print out -1. For this problem, we notice that it is difficult to delete edges and update the shortest path after we delete the edges. So we can instead reverse the entire process and add edges instead. So because n is small, we can maintain the shortest paths between any 2 vertices using the Floyd-Warshall algorithm. So each time a new edge is added, because we reversed the process and now only need to add edges, if the edge is from A to B with length c, then we can update the shortest paths from any other vertices. So, for example, for the shortest path from vertex I to vertex j, then it has 2 options, which is to pass through the new edge or to not pass through the new edge. So if it passes through the new edge, then it can go from vertex A to B or in the other direction from vertex B to A. So this part is the distance between vertex I to A plus the length of this edge, and afterwards the distance from B to J. If it goes in the other direction and passes through the new edge, then the shortest distance would be the distance from I to B plus the length of this edge and then the distance from A to J. Otherwise, if the shortest path does not pass through the new edge, then the distance would be dij. To update the shortest path from I to j, we can just find the minimum of these three distances. And let's look at the code for this problem. For this problem, we need to input all the edges, and afterwards, we input the queries. We need to record whether the roads are already blocked. So some roads might never be closed. So we need to keep track of whether each road is closed by a Boolean array blocked. So afterwards, we need to update the distances with the current available roads. So we first set all the distances to infinity, and afterwards, if the road isn't blocked, then we can update the shortest path with this road. And this part is just because the distance from I to I is always 0, so we update this. And afterwards, this part is just the Floyd-Warshall algorithm to update the shortest path. And we need to be careful that the loop for k needs to be on the outside and I and j inside. So afterwards, we can loop through the queries. So if this query is to close a edge, so in this case, because we reversed the process, we will instead need to add edges. So to add an edge, we will need to update the other shortest paths accordingly. So the update will just be if the road doesn't pass through that edge, then the distance would still be djo, and afterwards, if it passes through, this part is just if it passes through from A to B, and this part is if it passes through the edge from B to A in both directions. So otherwise, if the query is to print out the answer, distance from x to y, and we can just push back d, x, and y, which records the shortest path between the two nodes. And afterwards, because we reversed the queries, we will need to print out the queries in reverse order. So if the answer is still infinity, then this means that there is no valid path that goes from node x to node y. So we need to print out -1 for this case. Otherwise, we need to print out the shortest path.